In this video, we're going to talk about the idea of how we can use algebra to solve problems that involve congruent figures. We know from the previous video that we saw that anytime we have we have a pair of congruent figures, we know that all of their corresponding angles are congruent, and we know that all of their corresponding sides are congruent as well. And we're going to use this idea, use this knowledge, to set up and to solve some problems that involve algebra. So in the first example, we're given that triangles ABC and ABC prime are congruent to each other. The very first thing that I'm going to do is go ahead and draw a picture. The first picture I'm going to call triangle ABC. The second picture I'm going to call triangle ABC prime. And before I even read the rest of this, I'm going to go ahead and I'm going to mark all their pairs of congruent corresponding parts. Angle A corresponds to and is congruent to angle A prime. B corresponds to and is congruent to B prime. And lastly, C corresponds to and is congruent to C prime. And then I'm going to go fill in the information that's been given to me in the problem. The measure of angle C is 4x minus 30. The measure of angle C prime is x plus 15. And the measure of angle A is 2x plus 35. So the two angles that I know are equal in measure are C and C prime. And the reason for that is because they're congruent to each other. So I'm going to set up an equation that sets the measure of angle C equal to the measure of angle C prime. I'm going to go ahead and mentally subtract an x from both sides. I'm going to mentally add 30 to both sides. And lastly, I'm going to divide both sides by 3. So the first part of this question told me to find x. I just did that. The second part of the question instructs me to find the measures of all the angles. Well, the measure of angle C is going to be relatively easy to find. I'm just going to go substitute in 15 in place of the x. So the measure of angle C is going to be 30 degrees. The measure of angle C prime should also come out equal to 30 degrees because they have to be congruent to each other. But I'm just going to go fill in here, and this will be a nice little check for myself so that I know that I've done this question correctly. And as I suspected, the measure of angle C prime does come out equal to 30 degrees. The measure of angle A and A prime are going to be the same. So that's going to be 2 times 15 plus 35. Or in other words, 75 degrees. And now that I've got the measures of these angles, I can go fill them in here in my picture. Except I do need to backtrack just a little bit because I realize I made an algebraic mistake here. 2 times 15 is 30. 30 plus 35 is 65. So I'm going to go make that adjustment before I go any further. Now I'm going to go fill in the measure of my angles. So C and C prime were each 30. A and A prime were each 65. To find the measure of angle B and B prime, I'm going to use the fact that in a triangle, the sum of the angles has to total 180 degrees. So in other words, the measure of angle B plus 65 plus 30 has to sum up to 180 degrees. So whatever angle B is plus 95 has to total 180. I'm liking 85 degrees for the measure of angle B, which also makes the measure of angle B prime equal to 85 degrees. So again, in this question, we use the fact that when two triangles are congruent, all of their corresponding angles also have to be congruent. All right, let's go ahead and see what we can do with number 2. This one is a little different in that it looks at the sides instead of the angles, but it's the same in the idea that we're going to use corresponding parts of those congruent triangles. So we're given that triangle ADB is congruent to triangle CDB, and it's kind of nice for us that they already marked side BC congruent to side AD. We know then that side AB has to match up to and be congruent to side CD, and BD is a shared side, which again, I'm going to get used to marking anybody that's a shared part with an X. So I know that side BC and side AD are congruent to each other. As such, they have to have equal measures. So I'm going to go ahead and write a little equation that says 6a plus 20 equals a plus 60. So when I mentally subtract an a from both sides, I end up with 5a plus 20 equals 60. When I subtract 20 from both sides, I end up with 5a equals 40. And lastly, my algebra tells me that the value of a is equal to 8. So side BC is going to be 6 times 8 plus 20. And this time I'm going to be a little bit more careful when I do my mental math. 48 plus 20 is 68. And it wouldn't hurt to plug that in on my calculator. Side AD I would expect to come out the same. And if it didn't, I would know that I made a mistake somewhere along the lines of my algebra. Since it came out to be 68 also, I'm pretty convinced that the algebra that I did is indeed correct. Side AB and side CD are going to be equal in length because they're corresponding parts of congruent triangles. So 5 times 8 subtract 12 is going to make the lengths of these two sides equal to 28. Now, part of me at this point wants to go on and find the length of BD, but there's no real way that I can do that. And notice that it says the 4 sides of the quadrilateral. Well, I found the length of the left side of the right side. I found the length of the top side and the bottom side. So I'm indeed done for this particular problem. As always, at the top of the next page, I want you to summarize the key ideas and important understandings. Take a minute, think about what you just saw. What's going to be important for you to remember or to recall in the future? For the 2 examples where you have to apply what you learned, you're going to use what I talked about in the video, and I'm just going to give you a major hint here that in both of these cases, in order to solve these questions and find the length of all sides, you're going to need to use a little bit of Pythagorean theorem. A little bit of a squared plus b squared equals c squared. All right, so there's your hintage for questions 2 and 3 on the next page.